Hey everybody, let's talk about using trig to find missing lengths or angles. So the first thing you need to know is in order to apply the right triangle trig that we learned about in topic one of two things has to be true. Either we have one known angle, of course, aside from the right angle, because we have to know you have a right angle in order to have a right triangle. So we have to have a right angle and one additional angle, and know one of the three lengths. Or if you know you have a right angle and you have two lengths, then you can find what an angle measure is or the third side. So in these questions, we're going to be solving for either x or something else that we don't know. So here's the process that you should do. First of all, you're going to label which side is the hypotenuse, which side is the opposite side, and which side is the adjacent side according to some reference angle. Then, once we have that, we can pick an appropriate trig function based on what we know and what we want to find, and then we'll solve. Okay, so when I look at this first question, I'm going to use this 25-degree angle as my reference angle. See, I could, knowing that the other angle up here at the top is a 90-degree angle, I could find the third angle, but it doesn't matter which of these other two angles I use. The important thing is just pick one of these two angles that are not 90 and use that as my reference angle. So now that I'm going to say this angle right here, this 25-degree angle is my reference angle. Which side is the opposite side? That's over here. I'll label this as my opposite. Which side is the hypotenuse? That's the one across from the right angle. So here's the hypotenuse over here. And which side is the adjacent side? That's the remaining side next to the angle. All right, so now I know which sides are which according to this reference angle. Now I'm going to look and say, okay, which lengths or which ratio should I use based on what I know and what I'm trying to find? Well, I know this reference angle is 25 degrees. I want the length of the opposite side, and I know the length of the adjacent side. So I'll ask myself, which trig ratio should I use that compares the length of the opposite side and the length of the adjacent side? Well, if you remember the definition of each, let me pause and write that up here. Sine was the ratio of the opposite over the hypotenuse. Cosine is the ratio of the adjacent over the hypotenuse. And tangent is the ratio of the opposite over the adjacent. So in this case, since I want the opposite side right there, and I have the adjacent side here, then I'm going to use the tangent ratio. So first I've labeled, then I picked the trig function, which is going to be the tangent function, and now I'm going to write my equation. So the way it works is my equation is going to look like this. It's going to say the tangent of the angle 25 is the ratio of the side opposite x over the side adjacent 18. There's my equation. I'm going to solve for x. Well, here's how I can do that. So here I am over in the equation solver. And if I click on the button that says full pad, then I can use this trigonometry function here, and that will allow me to choose any of the trig functions. So the equation I want to write is the tangent of 25 is equal to the value of x over 18. That's the equation that I wanted to solve. The tangent of 25 is equal to x over 18. So I'll hit go, and it'll tell me what the length of x must be. If the tangent of 25 is x over 18, then as a decimal, x has to be the length of 8.39353 ... So depending on how I want to round, I believe I want to round to the nearest hundredth. That's 2 decimal places, so 8.39. Okay, so x is the length 8.39. Now I want to find the measure of this angle x. So here's the angle that I'm going to call my reference angle. So go ahead and label what has to be the opposite, the adjacent, and the hypotenuse. So in this case, I have the length of the adjacent side is 11. I have the length of the hypotenuse is 23. So I'm going to choose a function based on the two lengths that I'm working with in this case. Which lengths use the adjacent and the hypotenuse? That's the cosine function. So now let's write an equation for the cosine function. So my equation looks like this. The cosine of the angle, in this case it's x, is the ratio of the adjacent side 11 over the hypotenuse 23. So now let's use our equation solver to find that value. So I went to my equation solver and I typed in the equation, the cosine of x equals 11 over 23. And so it'll tell you two different options. There is a way to measure an angle that's called radians. And we're not going to focus on radians yet. That's something you'll learn later in your math career. Right now, we're just going to focus on the angle in degrees. So the value of x in degrees is 61.42 or 43 degrees. Okay, so there's the value of x to the nearest hundredth. Okay, in this question, I'm asked to find the perimeter of the triangle and round to the nearest hundredth. So the perimeter of the triangle is the sum of the lengths of the three sides. I know the length from the side B to C is 12 centimeters, but I don't know the length from A to B. I'm going to call this x, or from A to C, I'll call this y. But what they do tell me is that I have the measure of this angle C is 18 degrees. So since I know I have a right triangle, there's a right angle at point B, then I can, and I have the measure of this angle along with one side length, then I can use trig to find the other two sides. So step one is label the triangle with the opposite, adjacent, and hypotenuse side. So if 18 is the angle that I'm referring to, the side opposite of that is the side x, the side adjacent is 12, and then the hypotenuse, of course, is the length y. So I want to find both the lengths x and y. So I'm not going to write just one, but I'm going to write two different equations. One, I'm going to find the length of x, and then the other, I'll find the length y. So let's start with x. If I want to find x, the length of the opposite, and I know the length of the adjacent side, so let's write an equation that compares the length of the opposite with the length of the adjacent. Did you say we should use the tangent function? The tangent of 18 is equal to the length x over the adjacent length 12. There's my equation. So we'll solve this equation for x. So I just used 4 decimal places because I know my final answer is going to be rounded to the nearest hundredth, which is 2 decimal places, but I'm not there yet. So I'm going to keep 4 for now until I get to my final answer. So now I know the length of x and the length of the adjacent. I want the length of the hypotenuse. So this time I'm going to write a second equation. This equation will be to find the length of the hypotenuse y when I know the length from B to C was 12. So this time I'm going to use a cosine equation because the cosine is the ratio of the adjacent side 12 over the hypotenuse y. And I'll solve this equation for what the value of y has to be. So I found the length of y to be 12.6175. Again, I'm using 4 decimal places because I'm not ready to round for my final answer. Then I said the perimeter is the sum of 12 plus the length of x plus the length of y. Now I round to the nearest hundredth. In my final answer, 28.52 centimeters is the length of the perimeter. Okay? In this next question, we're talking about a rhombus. We learned about the properties of rhombuses before, so that still applies. We have a diagonal from A to C and B to D intersecting at point E. They tell me the perimeter of the rhombus is 32, and the measure of angle DAB is 46 degrees. So 2 things that are important to remember for this question, that a rhombus has 4 congruent sides. Why is that important? Because then I can take the perimeter, that's 32, divide that by 4 to find the length of each of the 4 sides. And then also, a rhombus has perpendicular diagonals. That's important because now I know that I can mark that these angles in here are all 90-degree angles. So I have 4 right triangles in this. Now, the goal is to find the length of the segment from E to B. So I'm going to call this length X right here in this triangle. Now, one other fact that I pointed out here is that the rhombus's diagonals bisect opposite angles. So when this angle DAB measured 46 degrees, that means each of these angles, DAE and BAE, each have to measure 23 degrees. Since the perimeter divided by 4 is 8, that means that each length of the sides of the rhombus is 8. Now, do you see how I have a right triangle, AEB, where I know the measure of the angle here, and I know the length of this one side there, and I want to find the length of a second side. So this is why this is where I can use trig. And because I have a right triangle, I know I have a right triangle because the diagonals are perpendicular. I know I have one side of the right triangle and I have one angle. I'm going to use the one angle and one side to find the length of another side of this triangle. So now let's write an equation based on the fact that I have this reference angle right here. So the first thing I'm going to do is I'm going to label what's the side opposite, the adjacent, and hypotenuse. So using 23 as my angle here, the side opposite is the length of x from E to B. The adjacent side is the one from A to E, and the hypotenuse is 8. So what equation can I write that involves the opposite side and the hypotenuse? It's a sine equation. The sine of the angle 23 as a ratio of this opposite side x over the hypotenuse 8. So now we can just go ahead and solve this equation for x, and that would be the length from E to B. So I solve my equation for x, and then I rounded because it tells me to round to the nearest integer. So the length EB must be 3. One more question here. This one I have to draw my own picture for. It says I have a right triangle, so let me start there. So it says I have a right triangle RTS, and the measure of angle S is my 90-degree angle. So I tried to do my best drawing of a right triangle, and I'm labeling angle S as my 90-degree angle. The goal is to find the measure of angle T to the nearest tenth of a degree. Now, the information I'm given is that this fact right here. It says if the cosine of R is a ratio of 19 to 36. Well, let's see, how is this going to be helpful in determining the measure of angle T? Well, there's two things I could do right now in order to do that. First thing is, I can remember that the equation for cosine says the cosine of some angle, I'll call the angle theta for right now, is always a ratio of the adjacent side to the hypotenuse, which means that I could use 19 as the length of the adjacent side, A, over the hypotenuse length, H. But that's in reference to the measure of angle R. So let me show you what that would look like on my picture. So if R is my reference angle, the adjacent side would be the length from R to S, that's 19, and the hypotenuse is the length from R to T, that's 36. Now, if I want to find the measure of angle T, one option is I could write an equation using angle T and solve for that. A second option would be to find the measure of angle R using this equation, and then I could find T because I know that the angle R plus the angle T must be 90 degrees, since the three angles of any triangle add up to 180, and angle S is already 90, that these two angles must add up to 90 as well. So let me show you the two choices. Okay, so here's one choice. I'm going to take the equation I was given, the cosine of R is equal to the length 19 over 36. So what I did is I solved this equation for the measure of angle R. That has to be 58.1 degrees to the nearest tenth of a degree. Then, since the three angles always add to 180, that 58.1 plus 90 plus this remaining angle has to be 180. I did 90 minus 58.1 to get 31.9 degrees. So one way to find the measure of angle T is by doing what I did right here. Here is another option. My other choice would be to write a different equation using angle T. So since angle T, if I change my reference to being this angle T, now the side opposite is the side R to S, and the hypotenuse is still 36. So I wrote a different equation that says the sine of T is 19 over 36. So I had the cosine of R was 19 over 36. The sine of T is also the 19 over 36 because I changed my reference angle. And so by solving this equation for T, I can get 31.9 degrees that way as well. Doesn't matter which equation or which approach you use, as long as you are referring to the correct angle when you write your equation, and then just making sure that there's always 180 degrees in the triangle. But there's a little bit of how we can use trig to find missing angles or missing sides.